Exercise 8.3 Problem 10 Discussion. Let's read the problem. Water in a cylindrical tank of diameter 4 meters and height 10 meter is released through a cylindrical pipe of diameter 10 centimeters at the rate of 2.5 kilometers per hour. How much time will it take to empty half the tank? Assume that the tank is full of water to begin with. So what they are talking is there is a tank which is full of water and that is going to be emptied. That is not emptied, I'm sorry, it's going to be emptied by half. So, and that water is actually getting discharged through a pipe and the rate of flow is 2.5 kilometers per hour. That's the speed of flow actually. And what they have asked is, they're asking us the time that it will take to discharge half the tank. Okay, so let's mark it. It looks little difficult. Let's break it as usual and make it simple. Okay, so let's talk about the tank. The tank is 4 meters diameter, height is 10 meters. Watch out, it is diameter and not radius, so which means you will have to convert it into radius. Okay, this is the diameter of the tank and it needs to be emptied half. Okay, then let's talk about the pipe. The pipe, cylindrical pipe. Cylindrical pipe means the cross section is circle. Okay, and the cylindrical pipe of diameter is 10 centimeter. Again, watch out, this is given in centimeters, whereas the tank wall is given in terms of meters. So you need to convert everything to meters. And the rate of flow, or the speed of water flow, is 2.5 kilometers per hour. Again, the unit is different. So let's make the unit in terms of meters. Okay, and it is hour. I think that also needs to be worked, or we can keep it as hour itself. Okay, so this is all is given in the problem. Let's list it out. The diameter of the tank is 4 meters. Height of the tank is 10 meters. Capital D and capital H. The pipe diameter is 10 centimeters. The rate of water flow is 5 kilometers per hour. Okay, that is actually 5000 meters per hour that needs to be converted. Now what are we asked? How much time will it take to empty half of the tank? How much time to discharge half the tank? This is what we are asked to calculate. Now let's think through. So whatever that is half the tank is going to get discharged, and that will be the water which is going to be flowing out. Okay, so now let's write the formula. So volume of discharge, how much of water is going to get discharged? That is half the tank. Correct? That's what they say, half the tank is going to discharge. But volume of discharge through a pipe is given by the formula area of the cross section into rate into time. So this is equal to this. You got it? Now let's develop an equation for that. What is area of the cross section of the pipe? That is a circle. Pipe, when you cut it, you'll be able to see only a circle there. So pi r square. R is nothing but the radius of the pipe. But diameter is given here, so that needs to be converted to radius. The rate of water flow or the speed of water flow, that is given as 2.5 kilometers per hour. I think I've made a mistake. It's not 5. It's 2.5 kilometers. I'll correct it a little later. Okay. So it's 2.5 kilometers per hour. Again, we'll need to convert this to meters into time. Okay. That is what we don't know. This is equal to what is the volume of a cylinder? Pi r squared h. And you want to empty only half of it. So half of pi r squared h. Capital R is the radius of the tank, which is half of 2 meters. Height of the tank, which is actually given 10 meters. Okay, so this is the equation, and then you can see except time everything else is known. So just by merely substituting this the variables and simplifying, you'll be able to get the value of time. Okay. So let me repeat, the key point is the volume of discharge, right? How much of water is going to get discharged? in a pipe is given by the formula area of the cross section, which is pi r squared, into rate into time. But we know it is going to be half of the tank, okay, because that's what we are asked to find. Half of the tank is going to get emptied. So you equate these two and simplify it and get this formula. Okay, so let's summarize the steps. Step 1. Convert the speed of water flow given in kilometers per hour to meter per hour. The rate is 2.5 kilometers, that is 2500 meters per hour. Okay, and that applies to the diameters also. I am not listed here. Please note that also. The diameter of the tank needs to be converted to radius, and the diameter of the pipe is given in centimeters. That needs to be converted to meters, and then radius must be taken. Step 2. Develop an equation for the volume of discharge in terms of capital R, capital H, small r, that is the radius and the height of the tank, and the radius of the pipe, the rate and time of discharges. Okay, that's what we saw earlier. That is volume of discharge equal to area of the cross section of pipe into rate into time, that is half the tank. So that on putting all the variables we get this equation. So this is the first step, or sorry, second step, because once you develop this, then the problem is easy to solve. So in this, time alone is not known. Then what we need to do is substitute the values of R, H, small r, and the rate in this equation and simplify it. We'll be able to get the value of time. Okay, so it looked very big, but as you see, if we break it, it becomes little easy to handle. So pause the video here and try to do the problem yourself, and come back and check your working against our solution. Okay, let's look at the solution. The diameter of the tank is 4 meters, so radius is 2 meters. Height of the tank is 10 meters. The diameter of the pipe is 10 centimeter. As I told, we need to convert this. Radius is 5 centimeter, that is equal to 5 by 100 meters. Let's keep everything to meters. Rate of discharge is 2.5 kilometers, so that is 2500 meters per hour. Okay, now you can see everything is in meters and the time is in terms of hour. We know the formula, volume of discharge equal to area of cross section of pipe into rate into time, that is half the tank volume. Okay, because they say whatever the volume of discharge is half the tank, and the volume of discharge in terms of for a pipe is given as cross sectional area into the rate of flow into time. Okay, so that is pi r squared is the area into rate into time equal to half pi r squared h. Pi r squared h is the volume of a cylinder, which is the shape of the tank. Because half the water is getting emptied, we'll have to multiply it by half, because only half is going to get emptied. Okay, now let's substitute all the values. So pi, the equation I'm writing it here for easy reference. Okay, pi radius, you know, 5 centimeters, so it's 5 by 100, 5 by 100, and the rate we know it's 2500 meters per hour into time equal to half pi capital R, the diameter or radius of the tank, that is 2 meters, 2 into 2, and height is 10 meters. Okay, so keep the time here and transfer all the other numbers. I think it will all get cancelled also, right? 100, 5, okay. So let's see, this will be, okay, these two zeros, and 100 will go here 25 times, and then 25 will go 4 times. So it will be 25 by 4 here. Okay, and this side it is 10 2s are 20. Okay, 2 and 2 will get cancelled. So this is 10 2s are 20 is sticking here. Okay, this 100 comes up the other side. Okay, let me explain. This 200 will go 25 times. Okay, this 25 into this 5 5s are 25. That is 625. 625 by 100. So that goes to the other side as 100 by 25. This 2 and 2 gets cancelled. So 10 2s are 20. So this is the right hand side. With this on simplification, 25 goes 4 times, 25 goes 25 times. And if you can simplify it, you'll get 3.2 hours. Okay, so the time taken is 3.2 hours. 0.2 hours means 1 hour is 60 minutes. 0.2 is 0.2 into 60 that is 12 minutes. Okay, either you can write it as 3.2 hours or 3 hours and 12 minutes. Okay, so please check your working against this solution and see if there's anything not right. If so, please correct it. And if you have not understood the concept, please go back to the discussion part of the video and review it. Okay, thanks for watching the video.